Okay, so today at night there's a lunar eclipse. So we're gonna try to find the diameter and distance to the moon. So if this is the Earth and this is the moon, then we know that the Earth's shadow is casted on the moon during the lunar eclipse. Well, here's news flash. The Earth's shadow creeps like this a bit. It bends. So now we have to find it here, and we can do this in terms of moon diameters. So what would be this distance in terms of moon diameters? Aristarchus the Greek assumed that this is 1/2 the moon diameter, and here is also 1/2. Then all you gotta do is measure the time it takes to cross the main part of the Earth's shadow, the dark part, to figure out how many moon diameters fit, and then add 1. And that's how many moons would fit in the Earth's diameter. Now, once we find the time it takes for the moon to go across the main part of the Earth's shadow, we need to figure out what moon diameters, how many moon diameters fit. Well, let's see. The moon is 1/2 degrees of the sky if you are seeing the sky as a sphere. This is a bit of spherical trigonometry. So if this is the sky, here's the moon. This, in terms of degrees, is 1/2 degrees. So how long does it take for the moon to travel its own length? Well, let's see. It takes about 24 hours for the moon to go 13 1/3 degree, or so all we need to do is take the time of the eclipse, which is from here to here, divided by 24 hours. And then multiply that by 13 1/3 degrees to find out how many degrees the moon traversed. And then we take that quantity and divide it by 1/2. And that's how many moon diameters fit in the darkest part of the Earth's shadow. And then we add a half. Then we add 1 moon diameter. And that's how many moons fit between from here to here. Okay, I have simplified the equation. So this shall determine the moon diameters that will fit in the Earth diameter. And by the way, the diameter of the Earth is about 8,000 miles. This is the moon before the eclipse. That is the moon before the eclipse. The lunar eclipse started, but the clouds covered the moon. Okay, the moon is in the umbra, or the main part of the Earth's shadow. There are clouds, but we're still in the middle of the lunar eclipse. I just need to find the moon. That's the moon in the eclipse. That's the blood moon, red moon. The moon is red because it's in a lunar eclipse. On the moon from the sun, there's red light. Because of that, the moon is red. Okay, so that's the duration of the eclipse, and the difference or the elapsed time is roughly along the lines of 2.5 hours. And that is from when the moon enters the umbra to when the moon is just about to exit the umbra. And I'm going to plug my value into the equation for the moon diameters that fit the Earth from earlier. And that is 2.5 divided by 12 times 13.3333, which plus 1, an extra moon diameter, which yields a value of 3.7777, which you'll see will give me a remarkable value. Now, it takes 3.7777 moon diameters to fit the Earth's diameter approximately. Diameter of the Earth is roughly 8,000 miles, and that is encompassing 3.777 moon diameters. Therefore, divide 8,000 miles by 3.777, and that should give you the diameter of the moon. And that value will turn out to be approximately 2,117.65 miles. That is the diameter of the moon. Once again, 2,117.65 miles. Calculate the distance to the moon. So there's the moon, and here's the person, and the angular diameter of the moon is 1/2 degree, as seen from Earth. Now, we can take the diameter of the moon, which is 2,117.65 miles, and then we got ourselves an isosceles triangle with the vertex angle of 1/2 degree. The base of the isosceles triangle is the diameter of the moon. Now, to find the distance, we have to take the altitude of that isosceles triangle, thereby creating a right triangle as we bisect it. Now, that altitude, or the long leg of that right triangle, is the distance to the moon, and therefore we can use the tangent of 0.25 degrees since we're dividing the angle by 2. So let's see. The tangent of the angle, which is 0.25 degrees, multiplied by d, the distance to the moon, should give you 1/2 the diameter of the moon, which would be 2,117.65 miles divided by 2. Solving for the distance d to the moon using algebra will get this equation that I have written. For the distance to the moon that I have calculated is 242,667 miles approximately. Now let's look at the actual values of the diameter and distance to the moon. So the actual diameter is 2,159.1 miles, and the actual distance to the moon is along the lines of 238,900 miles. So my percent error for the diameter is 1.92% below, and for the distance to the moon, it's 1.58% above the actual. So I was remarkably close in my calculations to the currently accepted values. Thank you for watching.